Whoa! Welcome guys. So this video, let's prove these results. So there are two questions that you might face in college number theory. So theorem says that if P is a prime, and we need to prove two things. The first thing is that if P is greater than 3, then the 24 divides P squared minus 1. Or basically P squared minus 1 is divisible by 24. And if P is greater than 5, then the 240 divides P to 4 minus 1. Or basically P to 4 minus 1 divisible by 240. Okay, so if this is the first time you come into my channel, then let me just still spend some time to introduce my channel. Oh shit, that bro. Okay, so let me introduce my channel. Okay, so I'm Eric. If this is the first time you come into my channel, then my channel is about to teach mathematics and physics from high school to graduate school. And if you're interested in abstract mathematics, then you can check my video list. And I will upload a math question every 1 to 3 days. So click the notification button and subscribe button so that you don't miss my latest video. Okay, now leave the comment and below and what you think like me to do in the future. Okay, so I don't waste you guys' time. Let's just keep solving. Okay, so let's see the first one. So the first one should be a trivial one. So let's I mean these two are trivial. Okay, so let's look at P is 3, right? So that means what? So in order to show P squared 24 divides P squared, we first show that we should show 8 P squared, right? 8 divides P squared minus 1, and the 3 divides P squared minus 1. So P squared can be minus 1, can be as a P minus 1, P plus 1. Right, so suppose you consider 3 consecutive integer, 1 is P minus 1, P and P plus 1. So 3 must divide one of them. So, right? But since P is prime, right? So 3 cannot divide P. So that means we have proved this, right? So 3 must be one of it. So now we only need to prove that the P squared minus 1 divisible by, it is divisible by 8. And this is very easy, right? Since P is odd prime. So I can say P is 2k plus 1, right? So let's see, P squared minus 1 is basically 4k squared plus 4k plus 1 minus 1. So it's 4k plus 1 plus 4k. So it's 4k k plus 1. Okay, so notice what? Notice that either k or k plus 1 must be even. Let me just write down either k or k plus 1 must be even. So this guy must be divisible by 8. So divisible by 8, divisible by 3, combine these two, 24 divides P squared minus 1. Okay, so trivial. Let's see this. So the second thing is also famous, that the 240 divides P to the fourth minus 1. So we can just directly, right? So we already show what? We already show 24 divides P squared minus 1, right? And so we know that the P to the 4 minus 1 is basically P to the square minus 1 times P to the square plus 1. So so that means 24 already divides this, right? So we only need another 10, right? Because 10 times 24 will be 240. So we just missed that 10. We just missed, so 10 is 2 plus 5. So we need another 2 and another 5. Okay, so remember that P is odd, right? So this guy P squared plus 1 must be even. So we already have 1, 2. So the key is that we need to find. So we need to find 5. Okay, so there are many ways to do this. So one easy way, the easiest way is to use the Fermat-Little theorem. So if you don't know what is Fermat-Little theorem, then I will you can check out here. I will put a link. So the Fermat-Little theorem says that if you given A, which is prime to P, which is prime to some P, basically P is 1, then you can proof the results tell you that a to the p minus 1 divisible by a to the p minus 1 to the power p minus 1 is divisible by p. The remainder must be 1. The remainder must be 1. Okay, so this is ma p. Okay, so if you notice that you can choose a to be p and band notation and the p to be 5. So you put in, you get p to the fourth is 1 ma 5. So basically p to the 4 minus 1 must be divisible by 5. Okay, but yeah, but in this case let's do instead, let's check it. So this is also an easy example that one can check. So I can consider p is 4k plus 1, right? Or p is 5k plus 1, 5k plus 2, or 5k plus 3, 5k plus 4. Okay, so what is the p to the 4 divided by what is the remainder of the divisible divided by 5? So it's 1, right? And then what is this? So it's 2 to the 4th divisible by 5. So the remainder is also 1. So basically 16 times equals to 3 times 5 plus 1, right? So the remainder is still 1. Or I can write as 2 to the 4 equals to 1, 5. And also 3 to the 4th is 81, right? So 81 is not divisible by 5, but if you divide 5, the remainder is 1. So 81 is 1, 5. Also 4 to the 4th can be changed as a minus 1 to the 4th. So definitely 1, 5, right? So combine 4 of them, we get the p to the 4 minus 1 must be divisible by 5. Okay, so combine all we have. We already have 2 and 5, and we already have 24. So it's easy to prove that. So we already get the results that 240 is basically divided by p140 divides p to the 4 minus 1. And maybe in a future video, one can prove that you can generalize this into some very, very crazy results. So to the p to the 2 minus 1 to some interesting things. Okay, and I will prove the general results maybe in a future video. Hope you guys subscribe to my channel. Thanks.